What's up, you freaking geniuses? So in this video, I'm going to teach you how to classify and identify different types of triangles in the coordinate plane. And I'm also going to show you how to check if they are right triangles. All right, so let's start with this first example right here. So we have triangle ABC. Now the first thing that we want to do is just plot the coordinates, right? So A, B, and C, right? So A over here, let's see, it's at -2, +3, right? So A is at -2, 3. B is at 2, 2, right? B is at 2, 2. And C is at -2, -1. Okay, C is at -2, -1. All right, now to find the distance between any 2 points, we can use the distance formula. So again, the distance formula is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared, all right? So first let's find the distance from A to B. So the distance from A to B. Okay, so now let's subtract our x coordinates first. So here our x coordinates from A to B are -2 and +2, right? So we're going to say -2 minus +2. And that's squared, and then we're going to add that to the y coordinates. So the y coordinate here is 3, and the y coordinate here is 2. So 3 minus 2, right? So then plus 3 minus 2 squared, right? So then this is going to be equal to -2 minus 2 is equal to -4. And that's squared. And then plus 3 minus 2 is just 1. So here we have 1 squared. All right, so then here, -4 squared is equal to +16. So then this is equal to the square root of +16. And here, 1 squared is just equal to 1, so plus 1. And so then this is equal to the square root of 17. And if you plug this into your calculator, you'll get that this is approximately 4.12. All right, now let's find the other two distances. So from B to C and from A to C. All right, so from B to C and from A to C. All right, so then these are going to be equal to, again, the big old square root, right? So now we're finding the distance from B to C. So we're going to subtract the x coordinates from B to C, right? So here we have a 2, and here we have a -2. So we're going to say 2 minus -2, right? So we're going to say 2 minus -2. And again, this whole thing is squared. And then we're going to add that. All right, now let's subtract the y coordinates. So we have 2 and -1. So we're going to say 2 minus -1, right? So we're going to say 2 minus -1. And again, this is squared, right? So then this is going to be equal to, so here 2 minus -2 is the same thing as 2 plus 2, which is equal to 4. So here we have 4 squared. And then we're going to add that to this one over here. 2 minus -1 is the same thing as 2 plus 1, which is equal to 3, right? So then here we have 3 squared, right? So then this is equal to 4 squared is 16, and 3 squared is 9. 16 plus 9 is equal to 25. So the square root of 25, as we know, is equal to 5, all right? Now lastly, we just need to find the distance from A to C, all right? So the distance from A to C. So again, subtracting our x coordinates, so from A to C, right? So here we have -2, here we have -2. So we're going to say -2 minus -2. All right, so we're going to say -2 minus -2. Again, this is all squared, and then we're going to say plus the y coordinates, which are 3 and -1. So we're going to say 3 minus -1, right? So 3 minus -1, and again, this whole thing is squared, all right? So then, finally, we can say -2 minus -2 is the same thing as -2 plus 2, which is equal to 0. So then here we just have 0 squared, plus, here we have 3 minus -1, which is the same thing as 3 plus 1, which is 4, right? So then 4 squared, right? So then here we just simply get 0 squared is obviously 0, and 4 squared is equal to 16. And the square root of 16 is equal to 4. Okay, great. Now we have all three lengths, right? So 4.12, 5, and 4. So based off these lengths, is this triangle up here scalene, isosceles, or equilateral? Well, as you can see, since all of the lengths are different, that means this triangle is scalene, right? Because a scalene triangle, all the sides are different lengths. Now, what would we have to have seen here in order to know that this triangle was either isosceles or equilateral? Well, in an isosceles triangle, remember, two sides are the same, and then we have one side that's different, right? So then here, you would have seen two lengths that are the same, right? So maybe this bottom one, what if this bottom length was 4.12? Okay, well, this length and this length are the same, and then we have one that's different. So then if this were the scenario, we would have known that this triangle is isosceles. Okay, now what would you have seen here if this triangle were an equilateral triangle? Well, an equilateral triangle, all the sides and angles are the same, right? So an equilateral triangle, they're all the same. So if this side over here was 4.12, that means this side would also be 4.12, which means this side down here would also be 4.12, okay? So if we saw all three sides down here were the exact same length, then again, we would have known it was an equilateral. Okay, but that was obviously not the case for this specific example. Again, this is just a scalene triangle. Now, how do you check if it's a right triangle? Well, for that, we would have to use the Pythagorean theorem, all right? So if you remember the Pythagorean theorem, it just says a squared plus b squared is equal to c squared, where a and b are the two shorter sides and then c is the longest side, okay? So again, if the distance, and I'll just write it over here, from a to b was 4.12, the distance from b to c was 5, and the distance from a to c was 4. Here we can take the two smaller sides, so 4.12 and 4, so that would be a and b, and then 5 would be c, right? So here we can say 4.12 squared plus 4 squared is equal to 5 squared, all right? So let's check if this equation is true. So 4.12 squared is equal to approximately 17, and then we're going to add that to 4 squared, which is 16, and we're going to set that equal to 5 squared, which is 25. 17 plus 16 is equal to 33, and 33, is that equal to 25? No, it's not, all right? So then that means this triangle, this scalene triangle, is not a right triangle. Okay, if this equation was true, if these two sides would have equaled each other, then yes, this would have been a right triangle. So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below.